Hi guys, welcome back to Solve for X. So today we are going to be simplifying identities. We are still under trigonometry. So the first question is sine x times tan x times cos x. So the first step that we're going to do here, we are going to change tan x into sine x over cos x times cos x, right? So this multiplies there. So sine x times sine x is sine squared x. Cos x and cos x, they reduce to 1. That's the answer. So 1.2. So you have tan x times sine squared x plus tan x times cos squared x. Okay? So here you see you have 10x and 10x this side, so you can then take out the common factor. So the common factor here is 10x, right? So you say 10x into sine squared x plus cos squared x, right? But you know that sine squared theta plus cos squared theta equals to 1. Therefore here this tends to 1, so it's 10x times 1, which will give you 10x. Okay, let's get another question which says that, let's say 1.3, we have sine squared x cos x plus cos cube x all over cos x. All right, and then let me give you some time to do this one, so you can just pause the video, try and work on this one alone, and then we will continue. Okay, so let's do it. I hope you paused the video and you worked on the question. Now here are the corrections. So there you are going to take out the common factor on top. So the common factor is cos x into sine squared x plus cos squared x. Should you multiply cos x inside, you're going to get that all over cos x. So cos x and cos x reduce to 1. Therefore, sine squared x plus cos squared x will give you 1. So as we have discussed it there, then you get 1. Right? That's your answer. Let's do 1.4. So you have sine x plus cos x all squared all over sine squared x minus cos squared x. Right. So now here, what you're gonna do here, you are going to consider this or you take this as the difference of two squares, because it is indeed the difference of two squares. Sine squared x minus cos squared x. The difference of two squares is understanding that when you are subtracting two perfect squares, then we get the difference of two squares, right? So consider x squared minus 9. The square root of x squared is x, so you write x and x. The square root of 9 is 3 and 3, so then the signs negative and positive. This is the difference of two squares as you have here. So on top you are going to expand that by saying sine x plus cos x into sine x plus cos x, right? All over you have the difference of two squares here, sine x, right? And then you have cos x and cos x. So the signs as we did there, it's gonna be minus and plus, right? So then this one and this one will reduce to 1. Then we're remaining with sine x plus cos x all over sine x minus cos x. Now you cannot simplify this one any further. Okay, now let's move to, okay, let's simplify this one. Simplify, let's say number 2. Simplify 1 minus sine squared x all over cos x, right? So now let's go back to this. Sine squared theta plus cos squared theta equals to 1. Therefore cos squared theta could be written as 1, take this sine squared theta, transpose it, minus sine squared theta, right? So that means this we can write it as cos squared x all over cos x. So this cos x will go with only one cos x there, then the answer is cos x. Okay, that's it. Now let us move to, remember you can rewind the video, pause, make me go faster or go slower until you understand. Right? Okay, let's prove now. Let's move into proving the identities. Prove the following. Prove the following. Let me just change this paper because there are a lot here. Okay, yeah, prove the following. So you have sine x plus cos x all squared equals to 1 plus 2 sine x cos x. So we need to prove this. Okay, so how you are going to prove this actually? Okay, how are you going to prove it? Are you gonna take this side first or you're gonna take this side first? I say we go with the left hand side. So left hand side equals to sine x plus cos x, okay, all squared. So expand this, so you have sine x plus cos x times sine x plus cos x. Okay, now sine x times sine x is sine squared x. Okay, sine x times cos x is sine x cos x. Cos x times sine x is sine x cos x. Cos x times cos x is cos squared x. Now look at this one. Sine squared x plus cos squared x equals to 1. So you write 1 plus sine x cos x plus sine x cos x is 2 sine x cos x. So therefore left hand side equals to right hand side. Therefore left hand side equals right hand side. Now let's go to this one. Let's say this one was our number 1. Number 2, let's consider this one. Sine theta cos theta 1 minus cos theta. Okay, again, take this as the difference of two squares. All right, so you have to prove that left hand side equals to the right hand side. So we're going to start with this one. Left hand side equals to, okay, so then what you're gonna do, you do this brackets sine squared theta times sine squared theta will give me that, and then also cos theta cos squared theta will give me that. So the signs has to be different. Okay, that's it. But this one is going to give me what? This is going to give me 1. Right? This is going to give me 1. Then I remain with what? I remain with sorry, I left 2 here. I left 2. Sorry, I left 2. I left 2. 2. Sorry, I left that 2 there. So this is gonna be 1. Therefore, the answer is gonna be sine squared theta minus cos squared theta. This is my left hand side. So I leave it like this, and I go to my right hand side equals 1 minus 2 cos squared theta. Okay, so now 1 could be written as sine squared theta plus cos squared theta plus 2, sorry, it's minus 2 cos squared theta. So then this and that will give me sine squared theta minus cos squared theta. So I'm going to hold it there, and please do go to your previous question papers and try and find questions that you can solve. For now, please don't forget to subscribe, comment, and share the video. Follow us on TikTok.